Alrighty, welcome back, boys and girls. It's your main math man, Miss Shank, coming to you live from Alameda International High School. In this video, we're going to be working through this functions quiz, so that way, you can have a nice little walkthrough if you need to do any type of corrections. So on this whole front page, there's not really any calculations because you're just labeling the slope or you're labeling that y-intercept. And so let's go kind of through how these are set up. So for number one, it says label the graphs with the correct type of slope. So your options are 0, positive, or negative. And so you're kind of looking at these lines of your functions, and so you're always moving left to right, just like a sentence. So as you're tracing over from left to right with this first graph, you're saying, hey, what is happening to my y values? Meaning my graph is going down, so I can say this one's going to be negative. And then I can say, all right, cross that one out since I used it. For this far right one, I can say as I'm moving left to right, what's happening to my y values? Well, they are going up, so that means it's going to be positive. So I'd say this is going to be a positive slope. And then I notice for this middle one, well, what's happening? See, notice how there's no change in your y values. That means that the slope is going to be 0. So again, if it's going down and to the right, it's negative. If it's going up to the right, it's positive. And if there's no change, it's a 0 slope. In number 2, it says the table contains solutions to a linear equation. When graphed, what would be the slope and y-intercept of the line? So let's first figure out our slope. So again, always have slope is the change in your y values over the change in your x values. And so let's kind of see what those look like. Again, I can do my y values first. So I'm going to say, all right, from one point to the next, what is my change in y values? So I say, okay, what's my change in y? Well, from -11 to -6, I'm increasing by 5. And if you notice, it should make a pattern. So as I'm going kind of down this ladder, if you kind of think of this as a ladder, you're taking one step at a time, and you're saying that each of these values are increasing by 5. And I can say, okay, what's going to be my change in my x values? Again, I need to make this as a ratio, meaning a fraction. So I'm just increasing my x values by 1. So notice how the pattern is set up for each of those ordered pairs. So then I can write it like this. I'm going to say I have my slope is going to be +5 over +1. So I'm going to say my slope is 5 for this one. And so let's kind of keep that right where it's at. And I can say, okay, what is our y-intercept? Again, that's always where your x value is equal to 0. Whatever that y value is your y-intercept. So for this one, we're going to say our y-intercept is going to be -11. So that means for this number 2, I would say my slope is 5. So the only one that has 5 as their slope is also the one that has -11 as our y-intercept. So we're going to say D for that one. In number 3, it says choose 2 true statements about the slope and y-intercept of the linear function shown. So it gives you a graph now, and I can say, all right, well, I can identify that y-intercept right away because I'm saying, okay, I highlight that y-axis. I'm saying, okay, where does that graph of our line hit this highlighted y-axis? So what I can do is I can kind of trace over. I'm saying, okay, where does this graph of our line hit that y-axis? We're going to say it's going to be at that point 2. So again, my y-intercept is where the function, and I can say hits the y-axis. Again, that's that vertical axis. So I'm saying, where does it hit? Well, it hits at that point 0, 2. So it's always where x equals 0. This is our y value. So when x equals 0, our y value is 2. So I'm going to say our y-intercept is 2. Okay. So that means this, I can now go for slope. And what I can do is I can go from one point to the next. I'm looking for ordered pairs. And what that means is this, I should be able to have an x and a y value along this graph of our line. And what I can do is I can say, well, I notice that, hey, it goes directly in a corner on these 2 points. So all I have to do is this. I can say, okay, what's going to be my change in y from one point to the next? So I'm going to go from this 0.2, or sorry, 0, 2 to this point 3, 0. So I'm going to go down 2 steps, so I have -2, and then I can go to the right 3, because I'm trying to get to that next point. So I have +3. Again, remember from here, we're saying our slope is always the change in y over the change in x. And so we can write it like this. I'm going to say my slope is going to be equal to, I can say it is -2 over +3. Since we're moving down 2 steps and to the right 3, and so I'm going to say my slope is -2 over 3. Again, notice how also too, thinking about that first question, notice how it's going down to the right, and so that means I have to have a negative slope. And on this last first page, or at the bottom of this first page, I should say, label the slope and y-intercept of each linear function. So always have your equations set up like this. It should always be y equals m times x plus b. And for some reason, a lot of people are messing this up, but that's okay because we're practicing now. So we're going to say our slope is m, so we're going to say this is our slope. So whatever value is attached to your variable x is going to be your slope. And then we're going to say our y-intercept is this entire amount. So we're going to say that's our y-intercept is b. So y-intercept. So whatever that value is, if it's minus or if it's plus, you have to include that entire amount. So for example, in that first one, I can say, all right, I have 1/4 as slope, so I'd say 1/4, and I'm going to say my -1 is going to be my y-intercept. So I have -1 as my y-intercept. Same idea for the next one. I have -3 as my slope, and I also have -3 as my y-intercept. For the last one, this one's a little bit trickier. You're only looking at that negative sign. You're probably thinking, well, what's the value to go along with it? If you're ever unsure, how many x's do you see here? Well, you say you have 1x, so it would be just -1. That means we're going down 1 step for every step to the right. And our y-intercept for this one is going to be +2. So I'd say +2. So again, real simple. Probably one of the easiest ones to do is just labeling those from the equation given. So now on back, make sure it kind of bled through a little bit. So let me switch this up for you guys. Okay. So now on the back of this one, this is where we do a little bit more calculations. So again, if you're ever unsure, if you're not confident in your abilities, again, use that Desmos calculator like I have shown in my other videos. Again, check out Shank's Domain on YouTube to be sure of how you set those up. For number 5, it says plot 3 points that are on the line of the function y equals -3x plus 2, and then use that function table to evaluate your points. So I give you the x values, and all you have to do is this. You have to take these x values and plug them into your function. Again, think of that vending machine. You're plugging in those values, selecting a point, and what comes out is your y value. So again, this goes into the function, and your y value is what comes out. So again, I can set it up like this. I can say -3, use parentheses to show multiplication. And so I have -3 times whatever my x value is, and I have +2. So I can say, all right, I'm going to have my first x value is -1, my second x value is 0, and my next x value is +1. Again, make sure you're taking these one step at a time. So let's say first I have this when x equals -1, I plug it in, and I can say, okay, I have -3 times a -1, same sign positive, so this is +3. +3 plus 2 is going to be +5. So I can say my y value for this is +5. And so this creates this ordered pair of -1, +5. Moving on to the next one, Negative 3 times 0 is 0. 0 plus 2 is 2. And lastly, I have negative 3 times 1 is negative 3. And then I have negative 3 plus 2 is negative 1. Again, if you're ever unsure, use that number line shown in the graph to be able to plot those points. Okay, so now that I have my table filled out, I now have these ordered pairs. So again, if you're unsure what those ordered pairs are, again, take one at a time. And so what I'm going to do is this. I'm going to say, all right, I need to plot the point -1, +5. So my x value, I take one step to the left for -1, and then I have to go up 5 steps for my y value. So that creates the ordered pair like this, -1, 5. So again, make sure you can have those ordered pairs if you do not already. Next ordered pair, I have 0, 2. So I go left or right, none, and then I go up 2 for my next ordered pair of 0, 2. And then also too, I can kind of notice using that slope, I can say, hey, my slope for this is -3. That means I go down down 3 steps. So I have -3 for every 1 step to the right. So if you need to build that staircase, you certainly can. That means my next ordered pair should be exactly like this. I go down 3 steps, so -3, and I go to the right 1 step, so +1. Again, we get that from our equation, and we can say, all right, my next ordered pair, 1 to the right, 1 down, which is exactly what we have. If you ever plot these points and they're not in a straight line, you know you messed up, because any of those linear functions have to be in a straight line. And so we know our function kind of looks like this. So let me use a straight edge, and let me say, as soon as I have those 2 points, I can draw that line for our function. In number 6, same kind of idea. It says select all points on the coordinate plane that represent the following function. A couple ways to approach this, and I can say y equals -2x + 5. What you can do is this. Let's plot a couple points, or let me evaluate, I should say. Let me evaluate a couple points. So I can say x, make my table, I have my rule, which is -3x, or sorry, -2x. Let's say -2x, and then +5. Make sure you can have your y values as well. So I have y. And let's just do a couple points. Let me have -1, 0, and +1. Let's plug these in. So I have -2 times -1 + 5. I have -2 + 5. Again, make sure you can make that pattern for yourself. So you're plugging in those x values into your function, and what comes out is your y values. All right. So again, I'm choosing these ordered pairs, or excuse me, I'm choosing these x values so that way I can see what y values come out and what y values go with specific x values. So when I plug in -1, I have +2, same sign positive, so I have +2 plus 5 is going to be 7. So my output is going to be +7, this is going to be 5, and this is going to be 3. Notice how our y values are decreasing by 2 each time for when our x values are increasing by 1. That's how we get our slope of -2, since we have a change in y over a change in x. So I can say, all right, let's find some ordered pairs. So this first ordered pair I could choose, again, I chose those x values. As long as you have 2 points, you can draw that line. So I have -1, +7, so I go 1 step to the left, 7 steps up, and hey, boom, there's a point. So I know I have to choose b for this one. So I know b is going to be on this line of this function. I can say 0, 5, so I go no steps left or right, and then I go up 5. I have another ordered pair, and I can do one more just to be safe. So I do 1 to the right, 3 steps up, which is going to be c. So I know I have these points. How do I check to see what other points are going to be on this line? Well, as long as I have 2 ordered pairs, again, I draw the first point, draw the second point, and draw the line. So again, as soon as you have 2 ordered pairs, you should be able to draw your line of your function. That means this. as I notice, I draw a line through my points, and what happens is my line of my function goes through these other ordered pairs. So that means that this point G and this point H have to be on our line. And what we can do is we can also prove that. So let me plug in G. So I have my x value as 3. So I can say when x equals 3, I have negative 2 times 3 plus 5. This is going to be negative 6 plus 5 is negative 1, which is our y value for G, so that checks out. And our x value for H is 5, and what should come out is our y value is negative 5. So let's find out. So I have negative 2 times positive 5 plus 5. This is negative 10. Negative 10 plus 5 is a negative 5, and so we know those do line up. So again, those four points, B, C, H, and G, are on my line of this function y equals negative 2x plus 5. And for number 7, it says which equation represents the same linear function in the table below. So the way to check this is I have to be able to plug in my x values, and it has to work for each of these x values. And so if I plug it in and it doesn't work, then I know I messed up. So let's do it like this. Let's say, I'm going to use some of this graph paper. So I'm going to say, all right, I'm going to choose this top right one first, because I think that one looks pretty good. And so if any of these x values give a different y value, then I know something is messed up. So let's have our list of x values. Let's have 4x plus 3, and then let's have our y values. So I have 1, 3, 5. So as I'm plugging these in, I can say, all right, I have 4 times 1 plus 3, I have 4 times 3 plus 3, and I have 4 times 5 plus 3. Again, all I'm doing is I'm plugging in my x values into my function, and what should come out is these values as well. So let's double check. 4 times 1 is 4, 4 plus 3 is 7. Again, it has to work for each of these ordered pairs. So if you just stop here, you don't know if it's right or not. So you have to prove it for each of these ordered pairs. 4 times 3 is 12. 12 plus 3 is 15. So far so good. And then lastly, 4 times 5 is 20. 20 plus 3 is 23. So since each of these ordered pairs match up, I know that this top right equation is the equation that goes along with this table. And then lastly, let's work on this wonderful page here. So let's have it like this. Okay, same kind of idea as number 5. I have my function, and so I say graph the function y equals 3 over 4 times x minus 1. Use this function table to evaluate your points. As always, take your x value and plug it into your function. Your output is your y value. And I give you those x values because I know for sure that those are a lot easier to evaluate. So that means this: I take my slope, 3 over 4, and I'm multiplying it times whatever my value of x is, and I'm getting an output. So let's kind of find out what these are. So I'm saying my first x value is negative 4, I have 0 and 4. Again, if you are unsure on how to multiply these two together, you can rewrite this as a fraction. So I have negative 4 over 1, again, is the same as negative 4. So I can say, work in my numerator first. I have 3 times negative 4 is negative 12. And I have divided by 4 times 1, which is 4. So I have negative 12 divided by 4 is going to be negative 3. And so I have negative 3 minus 1 is negative 4. So that means when x equals negative 4, my y value is also negative 4. So that's going to be that ordered pair, negative 4, negative 4. So that's my first ordered pair. Now I have when x equals 0, so that means this is going to be my y-intercept. That means if you look at this equation, when x equals 0, my y value is going to be -1. So I have the point 0, -1, and then I can say, okay, when x equals 4, I can plug this in. If I need to rewrite it as a fraction, that certainly works as well. So I have 4 over 1. And the reason why I'm doing this is because that way it's a lot easier to evaluate. So I have 3 times 4 is 12. 4 times 1 is 4. So I'm going to have, again, this is what I'm doing. I have 12 over 4 is the same as 3. I'm going to multiply the numerators, multiply the denominators, and then rewrite the fraction and simplify. So that means I have 3 minus 1 is going to be 2. So that means I have when x equals 4, I go up 2 steps for my next order pair. And notice how they are perfectly in line with one another. I can also check using that slope. I can say, all right, for every 3 steps up, so I go 1, 2, 3, so I have plus 3, I should be going 4 steps to the right. 1, 2, 3, 4. So this is plus 4. Again, I should be able to repeat that to get my next order pair. 1, 2, 3, plus 3, and then I have plus 4. So again, notice how I get those order pairs each time, and they fall directly on that line of my function. So again, be able to use that slope for yourself so that way you can easily graph those points. For number 9, it says a function of x contains 5 ordered pairs of the form x comma y. So again, this is always going to be your ordered pair. X is first, y is next. So I have a set of ordered pairs, and what I have to do is I have to list the domain, which is just the x values, and I can list the range, which is just the y values. So I'm going to say, all right, let's have these x values first. So I have x is going to be -1, -2, 3, -9, and 0. So let me write these down. Usually I like to write them from least to greatest. So I say -9, I have -2, I can say -2, I have -1, 0, and 3. So again, I have 5 order pairs, so that means I have 5 values of x, and then I can say, what are my y values, meaning my range. So my range is just going to be my y values in order from least to greatest. So I say, all right, let's do -2, I have 0, 4, 5, and 6. Again, real simple. Domain is x, range is y. Really, really simple. And lastly, for number 10, it says, which graph represents the same linear function shown in the table? So again, it gives you a table, going from the table to the graph. Quick thing I want to be able to do, identify first what my y-intercept is. So identify your y-intercept. That's the easiest one to be able to find because all I have to do is say, hey, when x equals 0, my y-intercept is -3. So my graph of my line hits at -3. So in graph A, it hits at 2, so I know it's not graph A. Or excuse me, it hits at 2, so I know it's not graph A. In graph B, it could be graph B because it hits at -3. So let's go to the next one. In graph C, it also hits at -3. And then in graph D, it hits at +2, so I know it's not graph D. So just by identifying my y-intercept, I'm able to eliminate 2 of these answers. So right away, it becomes just a true or false question. So next up, I can identify slope. Again, that's my change in y, change in x. Well, let's find out what those are. So I'm going from, I have from -5 to -3 is +2, and from -1 to 0 is +1. So that means this, again, I have my, like this, I'm gonna say my change in y is gonna be +2, and my change and x is going to be +1. So that means my slope is just going to be +2, which means I have a positive slope. If I compare B and C, this is a negative slope, where this is a positive slope. Again, notice how I'm increasing 2 steps for every 1 step to the right, so I know for this one it's going to be graph C. Again, make sure you can ask questions as needed, and as always, super slam that subscribe button.